When we heat solid copper, it absorbs heat and about 1080 degrees centigrade, it gets converted into liquid state. Melting copper absorbs more heat energy due to supplied heat energy, and slowly about 2500 degrees centigrade at atmospheric pressure, the liquid copper starts turning to gaseous state. Now consider a glass tube. It is very strong tube. It is assumed to be unbreakable due to high pressure and high temperature. Now take gaseous copper in this tube, and if you continue heating gaseous copper at extremely high temperature and pressure, then electrons become free and we get superheated mixture of ions and free electrons. This mixture of ions and electrons in superheated form is nothing but called as plasma state. In this process, solid copper gets converted to liquid copper, then gaseous copper, and then plasma state. On the basis of above discussion, we can classify matter into different states. So states of matter are solid state, liquid state, gaseous state, and plasma state. Gaseous state of matter can be studied with the help of basic gas laws. These basic gas laws are: first one, Boyle's law; second one, Charles' law; and third one, Gay-Lussac's law. According to Boyle's law, if temperature of gas not changing, that is, temperature of the gas maintained constant, and if volume of the gas increases, then pressure exerted by the gas decreases. According to Charles' law, if pressure acting on the gas not changing, that is, if we maintain pressure acting on the gas constant, then if temperature of the gas increases, then volume of the gas also increases. And according to Gay-Lussac law, if volume of the gas not allowed to change, then if we increase the temperature of the gas, then pressure exerted by the gas also increases. Thus, in Boyle's law, temperature is maintained at a constant, and while dealing with Charles' law, pressure is maintained at a constant, and while talking about Gay-Lussac law, volume is maintained at a constant. All the three laws we discussed above, we had considered the mass of the gas taken in the cylinder is fixed. Thus, from Boyle's law, we get equation volume is inversely proportional to pressure if temperature is constant, and from Charles' law, we get volume is directly proportional to absolute temperature if pressure is constant, and from Gay-Lussac law, we get pressure of the gas directly proportional to absolute temperature provided volume is maintained constant. So from three gaseous laws, we get three relations: first relation, second relation, and the third relation. Combining these three gas relations, we get PV proportional to T implies PV divided by T equals to constant, implies P1 V1 divided by T1 equals to P2 V2 divided by T2. PV proportional to T can also be written as PV equals to nRT, where R is a universal gas constant whose value is given by R equals to 8.314 joules per mole per Kelvin, where we can calculate small n by the relation n equals to n upon Na, where n stands for number of molecules of the gas in 1 mole divided by Avogadro number. Since we have PV equals to nRT, where n is nothing but n divided by Na, implies Na equals to, this n will come down, so n divided by n. And we also have R value. This R value, the R value is given by R equals to Na multiplied by Kb, where Kb nothing but called Boltzmann constant, where the value of Boltzmann constant is given by Kb equals to 1.38 into 10 raised to minus 23 joules per Kelvin. Now we have here PV equals to nRT. PV equals to n, and R value nothing but Na multiplied by Kb into T. PV equals to n. The value of Na is nothing but n divided by n. So Na is given by n divided by n Kb T. So we get n and n get cancelled. We get PV equals to n multiplied by Kb multiplied by T.